This is geometry, unit number 2, working on transformations. This worksheet's for reflection. It's called worksheet 2. Remember that the pre-image is the original shape and the image is the newer shape. We're going to take our segment and we're going to do a reflection for this. We look here and we see that our rule is negative x comma y. So that's going to mean that all your x values are going to change the value, but the y values are going to stay at the same height. So this is a reflection over the y-axis. Negative x comma y reflects over the y-axis. Notice that a negative on the first part is going to change where it's located. So instead of 3 to the right, it's going to go 3 to the left. Instead of positive 3, it's going to go to negative 3. Now we have A prime and B prime. Here we're going to reflect triangle ABC over the line y equals 3. So up at 3, we put our reflection line, and that's usually a dashed line. That's y equals 3. So what we do, we count up perpendicular to it. 3 to it, 3 past it. 4, 4 past it. 7, 7 past it. So this becomes A prime, this becomes B prime, this becomes C prime. Now think about what a reflection is. A reflection is folding the paper over. And notice that when you fold it, the C value is going to go to the top. Okay, as you fold it over, the C value goes to the top, and that's the way we have our image drawn. So for a translation, the shape stays exactly the same size and shape, and it's got the same orientation. It's just a slide. Here it's a reflection. So what used to point down now points up. It's still the same size and shape. It's still congruent. It just doesn't have the same orientation. So we're going to look here at our triangle ABC and our image A prime, B prime, C prime. We're trying to figure out what our line of reflection is. Well, the line of reflection has to be halfway in between. 1, 2, 3, 4, so it has to be half of that, so it's 2. 2 away from each other. That happens to be the line x equals 2. So when you count 1, 2, 3, 4, 5, 6, 7 to get there, you're going to go 1, 2, 3, 4, 5, 6, 7 to get past it. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you should be able to test to every point along the figure. Typically we only test the vertices. Here we're looking at a new rule. This rule is x comma y has a transformation for x comma negative y, x comma negative y, reflects over the x axis. Think about what changes when you put a negative y. Instead of going up, you're going to go down. The x amount stays the same, but the y changes its sign, so it's reflecting over the x-axis. So we have A prime, B prime, C prime, and D prime. Here we have the reflection of quad in the line y equals negative x. So y equals negative x is a linear equation with a slope of negative 1. So one way we could do this is to count perpendicularly to it. 1, 2 diagonals for D to get there. 1, 2 for it to get past. It's D prime. 1.5 diagonals, so we go 1.5 past. 1 diagonal, 2 diagonal, 3 diagonals, and a half. 1, 2, 3. And then the U is right on it, so the U has U prime right on it. So there is our image. When they start to overlap, I really like to be sure that we shade it in or use a different color to indicate. The rule for reflecting over y equals negative x is to switch our x and the y, and then to change both signs. That reflects it over y equals negative x. Here, we're going to reflect over the line y equals x, so that is a positive slope. We see that the Q is right on it, so it's not going to move. We could go diagonal, and then diagonal, and diagonal, and count your values. The rule for reflecting over y equals x is just to switch the y and the x, no negatives. So the original Q 7, 7, the original U 9, 2, -5, -3, 0, negative 3. So Q prime is going to be again at 7, 7, because you switch the x and the y and they land in the same exact spot. U prime is going to be 2, 9. A prime is going to be negative 3, 5. And D prime is going to be negative 3, 0. Now we notice that Q in a reflection, when you reflect it over that line, the Q is not moving. The U, 3.5, over 2 up 9, over 3, sure we did that right. 1, 2, 3. Looks like I counted that wrong. 1, 2, 3, 4. 1, 2, 3, 4. One and a half, and 1. D prime, A prime, U prime, and this here would be Q prime. So notice how I did that? I took the original points and I followed the rule. The rule would be X comma Y with our arrow follows that pattern. X comma Y with our arrow reflects over y equals negative x is that pattern. On the flip side, I'm doing some true and false. After reflecting a segment over the x-axis, the image will have the same x-coordinate but the opposite y-coordinate. So what that's saying, that if you take your figure, you'll have the same x value but the opposite y value, and that is true. After reflecting a triangle over y equals x, the x and y coordinates stay the same. Well, actually not. If you reflect it over y equals x, then the y becomes here and the x goes there, so that's actually false, because the x and the y are not staying the same. The x is becoming the y and the y is becoming the x. When reflecting a coordinate over the y-axis, and over the y-axis means right to left, so the negative value is on the x. The x-coordinate stays the same and the y-coordinate becomes opposite. No, it's the other way around. The x-coordinate becomes opposite and the y-coordinate stays the same. So again, that's false. When reflecting any coordinate over y equals 2. So if you're below it, you're going to go up 2. If you're above it, you're going to go down 2. You're going to count the distance it takes to get to y equals 2. We think that the image will have the same y coordinate, The image will have the same y-coordinate increased by 2. Well, it might increase by going up or it might decrease by going down. It's the distance until you get there. So this would be false also. We're going to match the following. When we switch, well, we haven't switched. It's still x and y. The only thing that's switching is the sign of the second. So that's telling you it's going up and down. So that's to reflect over the x-axis. And the reflection over the x-axis happens with graph D. The line y equals 2, all you can do is look at it. It's not graph D. It's not graph C. It's not really graph B. Y equals 2. You count the distance to get there and you count the distance past. Count the distance to get there and count the distance past. So graph A is number 12. When you keep the x and the y in the same order but you change the sign of the first one, so your x's are changing their location, you're reflecting over the y-axis. And here with graph C, we're reflecting over the y-axis. Here we're going to reflect in the line y equals x. So when you reflect there, you just switch the x and the y. So we take our line so you count 1 and a half and 1, 1, 2, 3 diagonals, or half a diagonal. The same amount, 1, 2, 3, 4, 5, 6 and a half, 1, 2, 3, 4, 5, 6. You're counting the diagonals to get to the line y equals x. So that is graph B. Last one. Draw the letter of your last name on the graph in the first quadrant with no letters touching. There it is. We're going to reflect your letters into the first quadrant, into quadrant 2. So to do that, we're going to first reflect over the y-axis. So the x values are changing for that to happen. Then we're going to reflect quadrant 2 into quadrant 4. So to do that, the only way to get there is to reflect it over the line y equals x. So you switch the y and the x. And then we're going to reflect it back to the first quadrant. So to do that, you're going to reflect it over the x-axis, so your y values change. So those are the different rules we're going to need to use. So let's figure out our pre-image. A pre-image coordinates 2, 6. 3, 3. 4, 4. 5, 3. 6, 6. So this was our A, this was our B, and our C, point D, and our point E. So we're going to follow the first rule here. So we're going to do A prime, and we're going to put a negative in front of each of the x coordinates. Two over, 3 over, 4, 5, 6. So we're going to get A prime, B prime, C prime, D prime, and E prime. Now we're going to reflect all of those into the fourth quadrant by reflecting it over the line y equals x. So now we're going to have A double prime, and to do that we're going to just switch 6, negative 2. B double prime is 3, negative 3. C double prime is 4, negative 4. DW prime is 3, negative 5. E double prime is 6, negative 6. There it is. So we get A double prime, B double prime, C double prime, D double prime, and E double prime. Now we're going to reflect this back into the first quadrant, which are A double prime is going to be putting a negative sign, which means change the sign on the Y value. So that's actually a triple prime now. Third move, so that's going to be 2 up, 3 up, 4 up, 5 up, 'So we'll trace that out in a different color. And that gives us our A triple prime, B triple prime, C triple prime, D triple prime, and E triple prime. You can see that some of the letters lined up right on each other. The C lined right up on the C. The E lined up right on the E. And the B lined up right on the B. So that was fun how it lined up like that, but not all the letters did.